Hi, in this video, I'm going to discuss on subtopic 3.4 double integrals in polar coordinates. Polar coordinates is used to represent your graph other than rectangular coordinates. Rectangular coordinates, like in the previous subtopic, your dA is dy dx or dx dy. Now your dA in this subtopic, your dA is r dr d theta, is in terms of r and theta. What is r, what is theta? Let's say if I have a point here, so the distance between the point and the center or the pole is r value. And how we calculate the theta? Theta is calculated from x is positive here until that particular line. So this is your angle theta. So this point can represent as r theta. Okay, since it's on Cartesian coordinates x and y, this point also can represent as x, y, as in terms of x and y. What is the relationship between rectangular and polar coordinates? Okay, let's, if I make this one as right angle triangle, so the distance here is y, since coordinate of y, so the point here of course y. Since the coordinate here is x and y, so the distance for here is x. Okay, by using theorem Pythagoras, x squared plus y squared is equal to r squared. So by theorem Pythagoras, x squared plus y squared is equal to r squared. And if you remember in trigonometry, you learn about SOHCAHTOA, which is sine theta is equal to opposite over hypotenuse. So sine theta, so opposite, which is y, over hypotenuse. If I rearrange, I will get y equal to r sine theta. If cos theta, adjacent over hypotenuse, so you will have x over r. So x itself equal to r cos theta. So this is two rectangular, so this is a relationship between rectangular and polar coordinates. So this is this that I explained just now, showed and prove the equations that given here. This equation also given in exam, so that you can refer when answering polar coordinates. So r squared equal to x squared plus y squared, x equal to r cos theta, y equal to r sin theta, and dA is r dr d theta. Don't forget the r here as is in formula. Okay, to furthermore the explanations, of course, what you should know at the end of this topic, you should know on how to find the limits of polar coordinates, and of course you should know how to evaluate until the end of polar coordinates. So we start with how to find the limit first. Okay, in previous level, dy dx you view as from bottom to top, and dx dy you view from left to right. How about polar r dr d theta? Please, you review from inside to outside, so from inside center to the outside, from inside to outside. Similar here, from inside to outside. So the view for r dr d theta is from inside to outside. Okay, for this example, okay, let's try the first example. Let's say I call it as region 1. Okay, from inside I saw r equal to 0, which is no distance at starting at pole. So r equal to 0, it will start. And the outside, we found that we have this equation. Just change this equation to polar. X squared plus y squared, just now I said is equal to r squared. So r squared is equal to 1. R equal to plus minus 1. In this syllabus, just choose the positive one, because we want actually positive or negative in polar is actually the same. Negative only represent the reflections. I don't want your region to be redundant, so just choose the positive only for polar in advanced calculus in this subject. in this subject. Okay, next, so you will have r equal to 1 at the outside. Okay, the shaded is represented by the angle. See, 0 until 1, 0 until 1. From 0 until 2 pi. 0 until 2 pi. So your angle will be from 0 until 2 pi. So how you write your limits? Your r is from 0 until, sorry, your r is from 0 until 1, and your angle is from 0 until 2 pi. Okay, done for the first example. The second example, as I mentioned, looks from inside to outside. From inside of the shaded region, you saw this one first, right? The equation of this one first. X squared plus y squared equal to 1. And the outside, you found this equation. Okay, so the inside is r. Okay, the inside is r squared equal to 1, r equal to 1. So the inside is r equal to 1. And the outside is r squared equal to 4, r equal to 2. So inside you found this line, r equal to 1, and outside you found r equal to 2, r equal to 2. Okay, and the angle start from here, 0 until here, 0 until here. Okay, everywhere from 0 until 0 until, so theta is from 0 until theta equal to pi. So your r is between 1 until 2, and your angle between 0 until pi. For your information, this is important information. Angle theta in polar, it should be in radian. That's why most probably when you see polar coordinate, theta will in terms of normally pi, because everything is in form of radian. Please note that. Okay, so the curve inside and outside, the shaded represent by the angle from 0 until pi, which is 180 degree here lah. Change into pi, you will get pi. Okay, so this represent on how to find the limits. To further your understanding, of course, I will try some more examples. Exercise 7, question A first. Read the questions. Evaluate the double integral by changing to polar coordinates. It's stated clearly, they ask you to change to polar coordinates. Same as your exam later. We will ask you clearly to change to polar coordinates for some particular question, especially when we want to ask you on polar coordinates. Okay, to find limits here, limits only can be found by the graph. So you need to sketch the graph first, then you can find the limits. Also, the region R is mentioned here, enclosed by the semicircle. X equal to negative 9 minus y squared. Okay, how to sketch this one? Please refer to my video on recall shape so that you understand more on how to sketch. Okay, this one, X always negative, so it's circle. Is semicircle at X always negative, so it's at this side. And the radius is 3y. Okay, I rearrange the equation. X equal to negative 9 minus y squared. So negative bring to the other side, become negative x. Bring to the other side, become squared. So minus y squared. I get x squared plus y squared equal to 9. The full circle is radius 3. The full circle is radius 3. From here, you can see the full circle radius 3. So that's why the point here is 3, negative 3, and this coordinate is 3, and the center is at 0, 0. Okay, this is full circle. See, the full circle is not the exact picture, because there's no, the exact picture is actually the third. Continue. Okay. Don't forget to shaded your region. Okay, shaded your region. So the region is at here. The inside the semicircle here. So the after you shaded your region, please do label your graph, your region R. because it stayed here r. Okay, so let's find the limit. So the limit for r is in between, okay, from center until this equation. So the equation, if I rearrange and change to polar, this one I have r squared equal to 9, r equal to 3. Some of you might questions, is it polar r equal to radius? Polar r equal to radius if your circle center at 0, 0 only. If your circle is not centered at 0, 0, like this example, r is not equal, polar r is not equal to radius r. Later I'm going to discuss this question as well, don't worry. Okay, continue. R, that's why I do this method. Just change to r, so you will get r equal to 3. So from center you get r equal to 0 until r equal to 3, and the theta angle is the shaded region here from pi over 2 until 3 pi over 2. So pi over 2 and pi over 2 until 3 pi over 2, see, until here. So pi over 2 until 3 pi over 2. So put this limit into your function, because they ask you to evaluate the function here. So you put the value into the function, double integral dA is r dr d theta as mentioned in the formula. Your dA become r dr d theta. If you want to integrate with respect to r and theta, of course the inside here you need to be in terms of x and in terms of r and theta as well. So just change xy here into polar. Okay, so change into polar, you will get negative x is r cos theta plus y is r sin theta. And the limit for r is 0 until 3, and limit for theta is pi over 2 until 3 pi over 2. Okay, let's solve. First, before we solve, I just expand first. I expand the r first. First, I expand the r inside here first. So I have r squared here, r squared here. So r squared, this also I have r squared, so I take it out. I factorize it, so I have negative r squared cos theta plus sin theta d theta. Okay, next, integrate with respect to, r I already multiply inside. So dr I not integrate yet, so don't forget to write your integral here, dr d theta. See, do you have these two integral? Of course you need the two respective variable. Okay, next, pi over 2, 3 pi over 2. I integrate with respect to r. I have r cubed over 3. Cos theta and sin theta become constant when integrate to respect to r. So it just follow here. Since we already integrate, so we just put the limit here. Dr already gone because the operation have been done. D theta you just copy because the operation not be done yet. Okay, next, put the value since you integrate to respect to r. Of course, the limit insert into r. Upper limit minus with lower limit. So pi over 2 until 3 pi over 2. So you put value, 3 power of 3 is 27, divided with 3 you get negative 9. Cos minus with, you put the lower limit, minus 0. So you will get negative 9 minus 0 is negative 9. Negative 9 cos theta plus sin theta d theta. Okay, next, negative 9 I can take it outside. So integrate cos, I have sin theta, and integrate sin, I have negative cos theta. from pi over 2 until 3 pi over 2. Okay, don't forget upper limit minus with lower limit. Minus with lower limit. So, negative 9 sine pi 3 pi over 2, you will have negative 1 minus cos 3 pi over 2 is 0. Minus with lower limit, sine pi over 2 is 1. Minus cos pi over 2 is 0. So you will have negative 9, negative 1 minus negative 1. I have negative 2. So your answer is 18. Done. So your answer will have constant as answer. Why? Because the outside limit is constant. Angle is always constant. That's why your answer is always constant. Actually, for chapter 3, your answer is always constant because your outside limit is constant. Okay, next. Continue for next example for B. Okay, the same exercise but question for B. For B, they don't give you directly what is the shape like question A. They give you in terms of integral. Okay, how to solve this kind of questions? Okay, please look up. This is dy dx. Dy dx means that the limit here is be found by viewing as dy dx, which means from bottom to top. So from bottom to top, at the bottom for limit of y, they meet y equal to 0, and at the top of the integral, they meet y equal to sub 4 minus x squared. Okay, the limit, to find limit, not just in polar, in everywhere, to find limit for polar, you need to sketch first. Okay, there's no other way other than sketch. So you need to sketch, then you can know how to find the limit for polar. Okay, continue. Okay, so the bottom here, you made y equal to 0. So the line y equal to 0 is here. So this is y equal to 0. And the upper line, you will make, okay, this is third. Third is half of something. What is that something? You can rearrange. It become x squared. Y squared. Okay. Squared, third bring to the other side, you have squared equal to 4 minus x squared. So x squared plus y squared is equal to 4. So the circle is radius 2. So I have a full circle with radius 2. However, the full circle is not your picture because the picture should be set in terms of set here. And y always positive. Y always positive. So the circle is only on top of y positive only, which is upper side. Okay, so this is circle with radius 2. So the label is 2. 2 and negative 2 here. So recheck. So if I look from bottom to top, I met y equal to 0 on the bottom, and on top I met of y equal to 4 minus x squared for this limit. Okay, now to shaded it, as I mentioned, shaded represent by the outside limit. Okay, shaded from 0 until 2. From 0 until 2. So from 0 until 2, you just shade it here. So this is your region. Don't forget to label region R. So this one represent your region as mentioned here. So from this diagram, now we change to now we find in terms of polar. So double integrals, x is r cos theta, dy dx. Your dy dx is actually dA, right? dAu in polar is r dr d theta. dA can be three things. dy dx, it can be dx dy, it also can be r dr d theta. Is represent the dA here. Okay, so the limit for r, you look from center to outside, from center to outside, you find 0 until this line, this line. So this line, if you rearrange, you will get x squared plus y squared equal to 4. So I change into polar. R squared is equal to 4. R is equal to 2. So means that you met from 0 until R equal to 2. So 0 until R equal to 2. That is limit for R. And limit for theta is shaded from here 0 until pi over 2. So angle 0 until pi over 2. So 0 until pi over 2. Okay, so you already have your function here. Now you just have to evaluate. Okay, to evaluate, just integrate. Just black one. Okay, the outside you just copy. D theta. Okay, integrate R. First, I multiply. Before I integrate, I multiply the R. First, R with this one, I have R squared cos theta. dr. Okay, I'm not integrate yet. I just multiply inside. So now I integrate with respect to R. So I have 0 until pi over 2. R squared become R cubed over 3. Cos theta. Theta you just bring. Just follow, because integrate to respect to R, the theta become constant. So just follow and then put your limit 0 until 2. The d theta follow because you not integrate yet. This one follow because you not integrate yet. Next, put value. Since you integrate to respect to R, of course the limit put into R. So your value will have 0 until pi over 2. 2 power of 3, you get 8 over 3. Minus 0. Lower limit, because lower limit minus with 0 you insert, so you get 8 over 3 and cos theta d theta. Next, 8 over 3 you take it out, so integrate cos, you get negative sin theta from 0 until pi over 2. Okay, so negative I take it out. 8 over 3 sine pi over 2 is 1. Minus sine 0 is 0. So you will get the final answer as, integrate. I'm careless here. Integrate cos. Integrate cos is actually sine, not negative sine. Lucky I realized it. Okay, so no negative. So no negative here. Just put value. So your answer will be at the end is 8 over 3. Done. Okay, please careful. Integration cos. You integrate, you get sine.